Yes, okay. I'll share my screen. Give me a minute. Welcome everyone to the maths class. Please confirm if you are able to hear me properly and see my screen, so we can continue the session. Can you hear me and see my screen? Yeah, thanks. Thank you for confirming. We are going to start the last topic of the subject, that is complex variables. The focus of this chapter is to understand these 5 topics, that is analyticity, complex integration, complex power series, and then zeros, singularities, and residues. Okay, so these are the 5 main aspects we'll be focusing in this chapter. Before we jump into the analyticity, I would like to give some small introduction about the complex number and variable. We know normal variable x, normal variable y, right? But how the complex variable will look like? We know the normal number, let's say 1, 2, 3. Natural numbers are there, prime numbers are there, even, odd. But what is complex number? So you all know that complex number is in the form of x plus iy, where I is nothing but the root of -1. Okay, if x and y are the real numbers, then x plus or minus I y is known as complex number, where I is root of -1. We know this. But what is complex variable? If you replace this x and y, if you replace this x and y, which are constants, with the variables. Okay, so now if x and y are the real variables, fine, but I term is there. So x plus or minus iy term is there, then we know that I is a imaginary unit, which is under root of -1. Hence, the resultant variable will be a complex variable. Okay, so x plus iy is a complex variable when x and y are the real variables. Okay, clear? So any complex number, you know, that can be written as x plus iy, or x, the conjugate of it is z bar, which is x minus iy. The mod of this complex number z is mod of x plus iy, and that is nothing but the under root of x square plus y square. Okay, so magnitude of, so I'm plotting this complex number on the graph, where the horizontal axis x represents the real axis, whereas the y-axis represents here the complex or imaginary axis, basically. Sorry. Then the point x comma y here represents the complex number. Okay, where x is a real coordinate and the y is a imaginary coordinate. And r we can see that is under root of x square plus y square, which will be the diagonal of this triangle, represents the magnitude of the complex number. And if you want to write the complex number in terms of r and theta, like in the polar form, x we know we can write it as r cos of theta, y we can write as r sine of theta. So x plus iy can be written as r cos of theta plus I times r sine of theta. If you take r common, it will become cos theta plus I sine theta, and we, you know, we can write cos theta plus I sine theta as e to the power I theta. So in short, a complex number you can write x plus iy, or you can write it as r cos of theta plus I times r sine theta, or you can also write it as r times e to the power I theta. So these are the variety by which we can represent a complex number. So you can represent it in a Cartesian coordinate system or in the polar coordinate system as well. You know this R, how to calculate R. The relationship between x and y and R is this. R is equal to x under root of x square plus y square. But how you will calculate this theta? Theta, you know, tan theta is y by x. Okay, tan of theta is y by x. So theta will be tan inverse of y by x. So that is how you will calculate the um, theta. Okay, so I hope you understood how a complex number looks like in the Cartesian and polar coordinate system. Another main part which we should understand as far as complex numbers are concerned, suppose on a graph I'm plotting a complex number. So it will be a point on a real axis and imaginary axis. So our x-axis is the real axis, y-axis is the imaginary axis. So z plus iy is 1 point. Suppose we have another point z0, may be origin or may not be origin. So for example, it's z0 is not the origin, okay, some other point. Z0 is represented as, let's say, x0 plus iy0. So x0 and y0 are the coordinates of point z0, and x and y are the coordinates of point z. So the shortest distance between them, so or the straight line distance between these 2 points z and z0 is represented by mod of z minus z0 or mod of z0 minus z. Okay, so this is the distance between z and z0 points. You can still represent this as x plus iy minus x0 plus iy0. Okay, um, because z is, you know, x plus iy and z0 is x0 plus iy0, so you can write it like this. And you know, whenever we are dealing with the modulus, what is it? It is so here you write it as x minus x0 plus I, you can take common and you can write it as a y minus y0. So it is something like x plus iy kind of equation. The magnitude, and magnitude is under root of x square plus y square, right? But in this case we have 2 points and we are dealing with the distance between them. So it is under root of x minus x0 whole square plus y minus y0 whole square. So this is basically the distance between the 2 points z and z0. Suppose that z0 point is the origin. What will happen? X0 will become 0, y0 will also become 0. So it is under root of x square plus y square, correct? So r is the radius of that circle, right? And so that will be equal to under root of x square plus y square. And you know, if you square both the sides, it will become x square plus y square equal to r square. And what is this? This is the equation of a circle with origin. And that is what we have considered, that x0 and y0 is 0, 0 because z0 point is at origin. Okay, so the equation number 2 represents the circle with the origin as a center, and this will be the generalized equation number 3, where radius of the circle or the equation of the circle is given by r square equal to x minus x0 whole square plus y minus y0 whole square. This is a general equation number 3. If you put x0 and y0 as 0, 0, it will become equation number 2, right? So if I want to focus on the points which are within the circle, which are lying on the circle, and which are outside the circle, I can use the complex number understanding and represent it. So look at this equation. So we started with z minus z0, right? This was our equation and we have derived it to this level, equation 2 and 3. So if z minus z0 is equal to r, what does it indicate? It indicates the equation of circle, right? So it means it represents the point which are lying on the circle. Okay, so lying on the circle means which are at a radius r from the center z0. Z minus z0 is less than r. What does it represent? Z minus z0 is less than r. It represents set of points lying inside the circle. Set of points lying inside the circle. And z minus z0 greater than r represent setup point lying outside the circle. Okay, so keep in mind, if it is equal to r, points lying on the circle, less than r, setup points lying inside the circle, greater than r, setup points lying outside the circle. I hope it is clear till this. Okay, a couple of more basic things about the complex number before we move to the first topic, analyticity. Just one more point, try to understand this. How you plot the equation of, let's say, um, or how we plot the function in a real, let's say, real variables. Okay, so I'll use a red pen here to draw it. Yeah, suppose this is our point, this is our x, and this is your f of x. Okay, y is equal to f of x. So y is equal to f of x is like this, y is equal to f of x is maybe something like this, right? So this is f1 of x and f2 of x, for example. So basically the function of x, a real variable, we can draw on a same graph, right? So for this value of, if I just consider only one figure, let's say this one, for this value of x, f of x is this. For this value of x, f of x is this, right? But in case of complex number, we cannot draw the complex function on the same graph. Why? Because to draw the complex number itself, we need one graph, one full 2D graph, because in complex numbers, we have a real axis and we have imaginary axis. So to represent a point A or represent a complex number itself, we need a graph. And then if you want to, so what is this complex number? 1 plus 2i. So z is equal to 1 plus 2i is the complex number. To draw the complex number on z, so we need one plane for it. Okay. And in order to draw the function of that complex number, we need another plane. So that is the difference. Here, look at the real variables. Just one plane is enough to draw the variable and the function, right? Y is a dependent variable, x is independent variable. Sorry. Yeah. But we can easily draw in case of real variables in a single graph, but in complex case it is not possible. So in order to draw the function of this, so this is how your z is equal to 1 plus 2i, then f of z here, which is u plus vi, again you need another plane. Okay, so corresponding to this value a, the value of the function is b maybe. Okay, and let's say that point is 1 comma 8. So f of z is 1 plus 8i, just an example. Okay, I'm explaining. So what we understand from it is to draw to draw a function of a complex number z, we need one extra plane. One plane is for z plane to draw the complex number, and another plane is to draw the complex function. Is it clear till this? So this is just to make you aware of the basics of complex numbers, which we should know before we jump into the actual topics of this chapter. Okay, one last theoretical point about the basics of complex number is neighborhood of point z0. If you remember the limit chapter of calculus, we said limit x tends to 0 or x tends to a from positive side or negative side. Okay, or limit x tends to a from the negative side. So we called it as left hand limit, right hand limit, right? You remember? So x tends to a means what? And x tends to a from the left hand side or right hand side means what? The points which are very close to a, right? Points which are very close to a from the right hand side, and points which are very, very close to the A from the left hand side. So basically, around certain region or around certain length delta, for example, around certain length delta, we can say it as a neighborhood of A. Okay, so for example, this circle I am drawing here. So this is your x and this is your f of x. Okay, so all the points lying here are in the neighborhood of A. Do you agree? This is in the case of a real number. The case of real number, all the points lying in A plus delta radius are called as, you can say, are the points which are in neighborhood of A. Okay, so you can use all these points. But in case of complex number, so I'll use a red pen here rather than drawing circle. I should use the horizontal line. So the points on the x-axis which are in neighborhood of A are all the points lying in this red line. Okay, let me use highlighter here. Or sorry, the laser pointer here. In this line, all the points lying on this line are in the neighborhood of A. And what is the neighborhood of A? A minus delta to A plus delta. But in case of complex number, we know to represent a complex number itself, we need one graph. So Z is equal to, for example, Z minus Z naught. So if you remember, what is Z minus Z naught is less than R or less than delta, is set of all the points within the circle of radius delta, right? So in case of complex number, the neighborhood of Z naught means all the points inside the circle with a radius delta and Z naught as a center. Okay, so this is how the neighborhood in the real number looks like, and this is how the neighborhood in the complex number will look like. I hope it's clear till this. So this basic knowledge is very, very important in order to understand the topics of this chapter. So the first topic of this chapter is analyticity of the function. Now you know what is complex function. So at least some basics we have to understand the analyticity of the complex number, right? So if you know, in case of real function, we said like continuity of the function, differentiability of the function, right? When a function is continuous, we call the function is continuous. When it is differentiable, in differentiability, we used to check whether function is differentiable or not. In continuity check, we used to check whether the function is continuous or not. In same way, we have the analyticity in case of complex numbers. Okay, so it's more or less differentiability of the complex function, you can say. Okay, it is more or less differentiability of the complex functions. Okay, in real function we have differentiability and continuity. In complex function we call it as a analyticity. Okay, so a complex function f of z is differentiable at a point z naught and also in the neighborhood of z naught. The f of z is called as an analytical function at z naught. Okay, so it's like you can clearly see it's more or less differentiability. So if a complex function f of z is differentiable not only at z naught but also in some neighborhood of z naught, then we call f of z naught as analytical function at z naught. Okay, so differentiability in case of complex numbers is called as analytical function. Next is singular point. Okay, next one is singular point. When we say singularity or singular point, if a function is not defined or not differentiable or not analytical at point z naught, then we say z naught is a singular point or z naught is a singularity. Let's take a simple example. Here f of z is z plus 4 divided by z minus 2. What will be the value of the function at z is equal to 2? if you see at z is equal to 2, denominator will be 2 minus 2 will become 0. So anything upon 0 is infinity. So f of z will become infinity at z is equal to 2. So you can say z is equal to 2 is a singular point for f of z. Similarly, if you look in the second function f of z, which is equal to z square minus 4 and divided by z square plus 4, here if you equate z square plus 4 equal to 0, then z is equal to plus or minus 2i is a singularity. So for the value of z equal to plus 2i or minus 2i, the denominator will become 0. And if denominator is becoming 0, the function is becoming infinite. Hence, z is equal to plus or minus 2i is a singularity here. Here, the next definition here is the entire function. What is the entire function? We understood analytical function. When a function is analytical, if it is differentiable at z0 and also in the neighborhood of z0, then we say the function is analytical at point z0. When we say a function is entire function, if a complex function z0 is analytical everywhere in the complex plane or throughout complex plane, then we say it as a entire function. I hope you are following it. When a complex function z0 is analytical everywhere in the complex plane, it means it is, if it is differentiable everywhere in the complex plane, then we call it as the entire function. Okay, so what kind of questions you can expect from exam from this topic? They'll ask you to check whether the given function is analytical or not. How will you check it? You can check it by using this theorem number 1. Okay, so theorem number 1 will help us to find the necessary condition for f of z to be analytical. So you have to check whether this condition is satisfied or not. If this condition is satisfied, then the function is analytical, otherwise not. Suppose f of z is is a function, complex function, which is u plus vi. U is a function of x and y, and v is also the function of x and y. And according to the Cauchy-Riemann equation, u of x is equal to v of y. It means if differentiation of u with respect to x, it is equal to differentiation of v equal to y, and differentiation of v with respect to x is equal to minus differentiation of u with respect to y. Okay, and all the derivatives ux, uy, vx and vy, this is the first case actually. Differentiation of u with respect to x, differentiation of u with respect to y, differentiation of v with respect to x, and differentiation of v with respect to y should exist. This is the first criteria. And the second criteria is differentiation of u with respect to x should be equal to differentiation of v with respect to y, and differentiation of v with respect to x is equal to minus times differentiation of u with respect to y. If these two conditions are satisfied, then the function is said to be analytical according to the Cauchy-Riemann. Okay, so this is the theorem number 1 which you should remember. And what you can expect from this is check whether the given function is analytical or not. Okay, or out of the given options, which function is or which option is analytical function. So you have to look for the given options and check which option satisfies this criteria, and you have to choose it accordingly. Okay, similarly in the polar form we have Cauchy-Riemann's equation. In polar form, the complex function f of z is represented as u plus vi again, but here u and v are the functions of r and theta. Previously u and v were functions of x and y, now they are the functions of r and theta. Okay, So let's try to look how the criteria will look like in case of polar form. So first criteria is all the derivatives should exist, that is differentiation of u with respect to r, differentiation of u with respect to theta, differentiation of v with respect to r, and differentiation of v with respect to theta. So all these four derivatives should exist. So that this is the first criteria. Okay. And what is the second criteria? Second criteria is this: differentiation of u with respect to r should be equal to 1 upon r times differentiation of v with respect to theta, and differentiation of v with respect to r is equal to 1 minus 1 upon r differentiation of u with respect to theta. So if these two conditions are satisfied, then we can clearly say that given polar form complex function is analytical. Okay. I would like to give one note at this point. Exponential function e to the power x, trigonometric functions, and hyperbolic functions such as sin x, cos x, sine of hyperbolic of x, cos of hyperbolic of x, and every polynomial function, that is a0 plus a1x plus a2x square plus so on till an x raised to power n, are defined everywhere. We know they are continuous and differentiable everywhere, right? And they are also integrable everywhere. Hence, they are analytical everywhere in the complex plane. Okay. So till now we studied that in case of continuity and differentiability chapter, that is basic calculus, we understood exponential function, trigonometric function, hyperbolic functions, and algebraic functions are continuous and differentiable everywhere. Hence, we can say they are also analytical functions in complex plane. They are analytical everywhere in the complex plane. Okay. The next one is if f of z and g of z are analytical, then f of z plus or minus g of z, f of z divided by g of z, and f of z into g of z are also analytical. Means if two functions are analytical, their addition, subtraction, multiplication, or division is also analytical. Okay. You should, in division, you should focus that f of z divided by g of z is given that g of z is not equal to 0. Because if it is equal to 0, anything upon 0 is infinity, and then it will not be a analytical function. So that point will be a singularity. Okay. So as I said, whenever you get a type 1 question that is test for analyticity of the function f of z, what you have to focus is f of z will be given. You have to decide which is u and v. U is your real part and v is your imaginary part of the function. Okay. Remember that. So this is your first step. Identify u and v from the given f of z. Second is check whether the derivatives of u and v with respect to x and y exist or not. So ux uy, vx vy, whether check whether these four derivatives are existing or not. If they are existing, then check the Cauchy-Riemann equation. Differentiation of u with respect to x is equal to differentiation of v with respect to y, and differentiation of v with respect to x is equal to minus differentiation of u with respect to y. If this condition is satisfied, then you can clearly say the given function is analytical. Okay. Another point you can check is like it is not needed, these two are enough. But what does this indicate? It indicates that your u, v, differentiation of u, differentiation of v, differentiation in terms of x and y are continuous. That is what it represents. Okay. This is the first type of question you can expect from the analyticity, that is check whether the given function is analytical or not. Okay. Another type of question what you can expect from the analyticity topic is construction of analytical function. You know, analytical function f of z will look like as u plus vi. So in order to construct the analytical function, they should either give you us the value of u or the v. So if u is given or v is given, we are supposed to find the rest. So if u is given, we are supposed to find v. If v is given, you are supposed to find u. Okay. In so and then combine them and get the analytical function. Okay. That is one way of solving the problem. But the easier way will be this. They'll either give u or v, and we have to calculate f of z directly. In order to find the f of z analytical function from either real part of or the imaginary part is this method. Suppose if u is given, you will find ux and uy, or if v is given, you will find vx or vy. You know f of z is equal to u plus vi. What will be the f dash of z? Differentiation of f of z with respect to x is ux plus ivx, or in terms of y, it will be uy plus ivy. Okay, right? And then what you have to do is, after differentiating it, you have to replace x by z and y by theta, and this method is known as Milne-Thomson's method. Once you do it, you will get f dash of z as some function. Let's call it as a g of z, because this function will be in the form of z, because you are replacing x with y, z, and replacing y with a 0. Okay, and then ultimately we will calculate f of z, which is the integration of this g of x plus c. Okay, and in case of complex numbers or the complex functions, the constant c is again c1 plus c2i. It's again a complex constant number. Okay, it's again a complex constant. Yeah. Okay, so I'll repeat the process. The construction of analytical function f of z is, first you have to find you have to check whether u is given or v is given, differentiate them with respect to x and y, calculate f dash of z, and then replace x by z and y by 0 in f dash of z, and then again integrate it with respect to z. You'll get a function in terms of z only. Okay, so will be your f of z. This is the type 2 question which you can expect from the analytical or analyticity topic. And the last type of question which you can expect from the analyticity topic is this: construction of harmonic conjugate. What is harmonic function? If you remember, harmonic function is, in physics you might have studied, or in the mechanics, double derivative of u, or del s square u equal to 0. If it is the equation, then that is an equation. If any function satisfies this Laplace equation, this is the Laplace equation, del s square u equal to 0. Any function that satisfies this Laplace equation, we call it as a harmonic function. So what is del square u? Del square u means d2u by dx square plus d2u by dy square equal to 0. I think my screen got freezed. Let me share again. Just a minute. Yes. So here, type 3 problem I'm explaining. If any function satisfies this Laplace equation, what is Laplace equation? That is del square u equal to 0. Del square u in the sense dou to u by dou x square plus dou to u by dou y square equal to 0. If this function is satisfied, then we say u is a complex, or u is a harmonic function. Okay. So I hope you understood the harmonic function. Then what is harmonic conjugate? If u is a harmonic function, then v will be its harmonic conjugate. Okay, and vice versa. If v is a harmonic function, then u is its harmonic conjugate. So this is the second question, or this is the third type of question which they can ask. If V is given, they'll ask you to calculate U. If U is given, they'll ask you to calculate U. In other words, they are asking you to construct the harmonic conjugate. In other words, they are asking us to construct a harmonic conjugate. Okay. Check if there is anything. Yeah. Yeah. So what is the process for it? So previously we have studied in type 1 problem what is the process. In type 2 problem, what is the process to calculate f of z, and in the third type, that is finding the harmonic conjugate, we should understand what is the process to calculate harmonic conjugate. So let's take this let's take this third type in more detail. Suppose V is given to you. Okay, try to understand. If V is given to you, V means imaginary part is given to you. Okay, and you are supposed to calculate U. Then how you will calculate U? You know U is x comma y, and differentiation of U, how it will look like? Dou U by dou x into dx plus dou U by dou y into dy. But you, they are asking you complex, they are asking you harmonic conjugate, right? The harmonic conjugate means function is harmonic function. In order to be a harmonic function, it has to be analytical. So it should satisfy the analyticity criteria. And first thing is what? As I already mentioned, if it is harmonic conjugate means the function is satisfying the Laplace equation. And what is Laplace equation? Del S square V del square V divided by del square V equal to 0, or in other words, dou 2V by dou x square plus dou 2V by dou y square equal to 0. Can you write it like this? Dou 2V by dou y square equal to minus dou 2V by dou x square, right? We can write it like this. And we also know one basic rule here. If you remember the see, look at this example, how it is looking like. Du is what? Dou u by dou x. If you remember the criterias for analyticity, what was the criteria? Differentiation of u with respect to x is equal to differentiation of v with respect to y, and differentiation of u with respect to x is equal, differentiation of u with respect to y is equal to minus differentiation of v with respect to x. This is what we have studied. This is the criteria for analyticity, this Cauchy-Riemann equation. So if can you replace this differentiation of u with respect to x as differentiation of v with respect to y? So I am replacing this term. Similarly, I am replacing this term, that is differentiation of u with respect to y as minus time differentiation of v with respect to x. Okay. So now I am writing total derivative of u du as dou v by dou y into dx plus minus dou v by dou x into dy. And this equation is more or less similar to the mdx plus ndy kind of equation. Mdx plus ndy. And then you know that mdx plus ndy kind of equation you can solve by exact non-exact method. And when we say function is exact function, the differentiation of m with respect to y is if it is equal to differentiation of n with respect to x. In other words, what we can say, m is what? M is dou v by dou y. So dou 2v by dou y square, if it is equal to minus dou by dou x of n. N is what? Dou v by dou x. So you can write it as minus dou 2v by dou x square. And if you simplify this, it becomes a Laplace equation. So what we get from it? in order to have a Laplace, or in order to satisfy the Laplace equation, it means in order to satisfy the harmonic criteria or becoming a harmonic function criteria, it has to be exact. Okay, so we proved that the m and n, or the given function, this entire differentiable equation is exact differentiable equation. And the solution of exact differentiable equation, is integration. So this is the du, right? So du is equal to m dx plus n dy. So u can be written as integration of m dx plus integration of n dy plus constant. In first case equation, if you are integrating with respect to x, y is a constant, and in case of second differentiation with respect to y, terms of n without containing x. I hope you remember this rule for the exact differential equation. Okay, so in short, m is what? M is differentiation of v with respect to y. So I will write vy. And what is n? Minus dou v by dou x. So my minus here I'll take vx, I'll write. Okay, so this is the final equation. You don't have to remember all this derivation kind of thing in exam. This is just to help you understand how this final formula came. Okay, so if u is given, and in order to calculate u, you can use this formula. Integrate considering y as a constant, differentiation of v with respect to y. Okay, minus integrate vx, means differentiation of v with respect to x. That term you have to consider without the terms containing x, and if integrate with respect to y plus constant. This is the formula to find u when v is given. Is it clear or not? If you have any doubt, feel free to ask. In the same way, if u is given, you can find v by using this formula. V can be written as minus integration of u with respect to y, considering y as a constant, dx plus integration of u with respect to x, considering terms without containing x, okay, plus c. Okay, so this is how you will find the harmonic conjugate. So just to recall everything, when we say a function is an analytical function, if the complex function is differentiable at point z0, or analytical at z0, if it is differentiable at point z0, and also in the neighborhood of z0. Okay, I'll repeat. What is analytical function? Okay, if function is differentiable, okay, if function is differentiable at z0 and also in the neighborhood of z0, then we say that that function is analytical function. What kind of questions you can expect in this topic? The first type is check whether the given function is analytical or not. Okay, that is the first type of question you can expect here. Okay, second type of question is second type is construction of analytical function. They'll give either u or v and ask you to calculate f of z. This is the construction of analytical function. And third type is finding the harmonic conjugate. If u is given, you have to find the v, and if v is given, you have to find u. So if v is given, this is how you will calculate the v. Sorry, this, if v is given, this is how you will calculate the u, and if u is given, this is how you will calculate the v. Okay, so these are the three types. Okay, 1, 2, and 3. First is analyticity check. Analyticity check. Second one is the construction of analytical function. And this is a harmonic conjugate. Finding harmonic conjugate. Okay. These are the three type of problems you can expect from this first topic, that is analyticity. Okay. So before we jump into the second topic, I would like to give you some questions uh, on the first point, that is analyticity, and then we will start the complex integration. Okay. So let me give you some questions here. Test analyticity of the function, or check whether function is analytical or not. Okay. F of z is equal to x plus e to the power x cos y plus I times y plus e to the power x sin y. Okay. X plus e to the power x cos y plus I times y plus e to the power x sin y. So I'll give you 2 minutes of time. Very simple question. Check whether the given function is analytical or not. Okay. Post your answer in the chat group. Anyone? Very simple question. Okay. Let me help you out with the answer. So here, this is your um, u, and this is your v, right? Because f of z is equal to u plus vi. Check whether u and v is differentiable with respect to x or not, and differentiable with respect to y or not. So ux is differentiation of u with respect to x is 1 plus e to the power x cos of y. Differentiation of u with respect to y is 0 plus e to the power x. Differentiation of cos y is minus sin y. Differentiation of v with respect to x is e to the power x sin y, and differentiation of v with respect to y is 1 plus e to the power x cos y. Okay. So check whether so all the derivatives are existing. So first criteria is satisfied. So second criteria is differentiation of u with respect to x if it is equal to differentiation of u v with respect to y. Check whether it is satisfied or not. Yes, they are same. Okay. So this condition is satisfied. Check whether differentiation of u with respect to y is minus times differentiation of v with respect to x. Yes, that is also satisfied. They are same, right? They are minus time vx. So both the conditions are satisfied. Hence, the given function is analytical. Okay. I hope you understood the method. Okay, let me give you one homework question on this. F of z is equal to rs square cos of 2 theta plus I times rs square sine of p theta is analytical. Okay, the given function is analytical upfront, they are telling. Then p find p, and the options are 0, 2, -2 and 1. Okay, these are the options. Okay, and the correct answer in this case is 2. Mm. Again, you have to apply the same logic here. Um, you have to figure it out what is u and v, and then solve the question. Okay, this is for your homework. You can try it, and if you still find difficulty, you can reach out to me. But here, what is u here? This is u, and this is v. So, in case of polar form, what is the criteria? First is u r, u theta, v r, and v theta should exist. And second criteria is differentiation of u with respect to r is 1 upon r differentiation of v theta, and differentiation of u with respect to theta is, sorry, differentiation of v with respect to r is -1 upon r u theta. Okay, so these two formulas you have to use, and then you should get the answer easily. So I have already given you the hint. With this hint, you should be able to get the answer. Okay, check your answer, and if you are still finding difficulty, you can feel free to reach out to me. Next type of question I'd like to give you: if v is given r comma theta, that is 3r square sine of 2 theta plus 2r sine theta plus 7. Okay, find analytical function. Try to solve. Solve it. See what I said, if v is given or u is given, differentiate it. So first step is you will differentiate v with respect to r and differentiate v with respect to theta. Differentiation of v with respect to r is 6r sine of 2 theta plus 2 sine theta. Differentiation of v with respect to theta is 6r square cos of 2 theta plus 2r cos theta. Okay. And what is f dash of z? F dash of z is equal to, yeah, if you remember, what was f dash of z? F dash of z, you have to write it as ux plus ivy in terms of polar form, or in case of, sorry, in case of Cartesian form, or in the polar form it is ur plus ivr into e to the power I theta. So it is f dash of z is differentiation of u with respect to r plus I times vr e to the power I theta. Okay, e to the power minus I theta. So e to the power minus I theta as it is. ur we don't know. Differentiation of u with respect to r we know as it should be 1 upon r v theta, right? So I will use it. So what I'm doing, I'm taking v of theta and dividing with r. So what will happen? It will become 6r cos of 2 theta plus 2 cos of theta, right? Plus I times 6r sin 2 theta plus 2 sin theta. Okay, like this it will look. Okay, so this is how your f dash of z will look like. And the next step is replace r by z and keep theta equal to 0. Okay, in case of polar, replace x by z and put y equal to 0. Okay, but in case of polar form, replace r by z and put theta equal to 0. So how the dash of z will look like? If you put theta equal to 0, e to the power 0 means 1. Replace r by z, so it will become 6z. Cos of cos 0 is 1, so 6z plus 2 plus I times 6z sin 0 is 0, and again 2 times sin 0 is 0. So basically this entire part will become 0. It is 6z plus 2 is 2. So f dash of z is 6z plus 2. And what is f of z? F of z is integration of it with respect to z. So it is 6z square by 2 plus 2z plus c1 plus c2i. Okay, like this. And 6 by 2 is 3, so I'll write 3z square. So this is the answer. Okay, so this is your f of z. Okay, I hope you are following it. Any doubt till this? Yeah. So this is how you will construct the analytical function. This is in terms of z. You can still convert it into the r and theta, but you know you have to replace z is equal to r cos theta plus I sin theta. Okay, that you can do, or you can keep in this format also, depending on the options. The next type of question is third type. V of r comma theta is equal to 3r raised to the power 4 sine of 4 theta plus 4. Find harmonic conjugate. Okay, what is the meaning of harmonic conjugate? You are supposed to find u from this. V is given, you are supposed to find u. What is the formula? Can anyone tell me? Yes. So the formula was u is equal to integration y is equal to constant m dx plus integration n dy terms without x, okay, plus constant k. Okay, this is in terms of a Cartesian coordinate system. So in case of polar form, how it will look like? U is equal to theta equal to 0 m dx. But what is the value of m dx plus n, sorry, not dx, it will be n dr, and it will be n d theta without y. Okay, first case is theta equal to constant, second case is without, sorry, without r plus k. Okay, so this is in Cartesian format, and this is in case of polar form. So you will use the second formula here. What is this m and n? See, if you remember how we calculated, how we derived this formula, it is derived from u. So differentiation of u is equal to dou u by dou r into dr plus dou u by dou theta into d theta. But u is not given, v is given to you. So you have replaced this by, what is dou u by dou r? It is minus 1 upon r, sorry, plus 1 upon r dv by d theta into dr plus, what is dou u by dou theta? It is minus r dv by dr, right, into d theta. So basically put here plus, put here minus. So this is your m and this is your n. Okay, so what is the value of m? 1 upon r dv by d theta, and what is the value of n? Minus r dv by dr. And we don't know what is dv by d theta and dv by dr, that we have to calculate. So I would like to I'll rub this part here because we are not using this formula, and we'll use this space to calculate m and n. So to calculate m, we need dv by d theta. What is dv by d theta? 3r square, or 3r raised to the power 4 as it is. Then 4 theta differentiation is cos of 4 theta into 4. So 3 will become 12. Okay, this is dv by d theta. So m will be 1 upon r dv by d theta. So it will be 12 r cube cos of 4 theta. In the similar way, what is dv by dr? dv by dr is 12 r cube sine of 4 theta. And what is the value of n? N is equal to minus 12 r raised to the power 4 sine of 4 theta. Okay, so in this formula, if I put, you will look like this: integration theta equal to constant m dr, m will be 12 r cube cos of 4 theta plus integration of n without terms containing r. So there is only one term and that contains r, so I should write it as 0. Okay, so this here is with respect to r plus here 0 d theta plus k. What is integration here? If you do integration of 12r cube with respect to r is 12 as it is, r raised to 4 by 4 cos 4 theta as it is plus k basically. Okay, so 12 by 4 is 3r cube. So the final answer is this: 3r cube, sorry, 3r raised to the power 4 cos of 4 theta plus k is the final answer. Okay, so this kind of questions you can expect. Let me give you one homework question on this. Let me check if the space is there. I'll give one homework question. Yeah, here we have some space. I'll give a homework question to you. U is equal to 3x square minus 3y square. Find V. Okay. So that U plus Vi is analytical. Or in other words, find the harmonic conjugate. Harmonic conjugate of U. Harmonic conjugate of U is V. That's all. And here they have given some options, but directly I'll give you the answer here is 6xy plus k. Okay. So you solve this problem. I have already solved the problem previously. The same logic you have to apply and solve it. Nothing different. 6xy plus k is the final answer. Okay. The options I'll give you if you want. 3y square minus 3x square plus k. B is 6x minus 6y plus k. Option C is 6y minus 6x plus k, and this is option number D. Okay, so these are the options. Option D is correct in this case. Yeah, so this is all about the first topic, that is analyticity. The second point of this chapter which should focus on is the complex integration. We have studied normal integration, we have studied improper integral, definite integrals, but how to do the integration in case of complex functions? That is what we have to understand in this topic. Okay, so integration over the curve C, f of z dz is given by this formula. Integration over curve C, f of z dz, where f of z is a complex function u plus vi. U is a function, u and v are the functions of x and y. Okay, you know z is equal to x plus iy, so dz will be dx plus idy. So if you put this u f of x and dz in the formula, how it will look like? Integration over a curve, f of z dz will look like as u plus vi times, or integration of this is dx plus idy. So if you multiply these two brackets, what we will get? U into dx minus v into dy plus I times v into dx plus u into dy. Okay, so real part as one integral, and this is the second integral, which is a imaginary. Okay, so this is a real part of the integral, this is the imaginary part of the integral. Clear? Any doubt? You understood how to represent the complex integral? Okay, so let me give you some question here. Evaluate integration 0 to 1 plus I z dz along the curve y is equal to x square. Okay, so I'll explain through figure. This is real, imaginary. Y is equal to x square is this graph, and from 0 comma 0 to this another point which is 1 comma 1, right? Because it's z 1 plus I is there. 0 means 0 plus 0 I. Okay, so and the function is y is equal to x square. Okay, like this is the curve. C. Okay, integration over curve C. Y is equal to x square from 0 to 1 plus I z dz. Integration 0 to 1 plus I z dz equal to how the function will look like. As I said, you can write it as 0 comma 0 to 1 comma 1, and z means what? X plus iy. And what is dz? Dz means dx plus idy, right? And if you remember, if you multiply it inside, what you will get? Integration. So now I will convert this entire function in terms of x only. So y is equal to x square. I can write dy as 2x dx. So can I write this function as 0 to 1, and so it will be x dx plus y dx times I. Y is what? X square dx times I plus x dy times I, and dy is 2x dx, so 2x square dx, right? And minus y dy, and y is x square and dy is 2x dx, so 2x cube dx. I hope you understood this entire equation. So what I'm doing is I'm replacing y with a y is x square and x with a and dy with a 2x dx. Okay. So overall integration 0 to 1 x dx. So anything which you can take common, or I think, yeah, I missed to write I here. So x plus x square plus 2x square is a 3x square I, and minus 2x cube dx. Okay, so this is a simplified version of it. So now you can just do the integration. Integration with respect to x is x square by 2 minus 3x cube, plus 3x cube by 3 minus 2x raised to the power 4 by 4. Integrate it from 0 to 1, and 0 to 1. Here I have forgot to write 2x cube. I already here. Yes, here I'll. Where is I? Yes, here. Yeah. So 3 will get cancelled. So if you replace x with 1, 1 by 2 minus 1 by 2, that will get cancelled, and other terms will become 0. So basically you will get I only. Okay. So this is how you will calculate the complex integral. Okay, so one more question I'll give for homework, which you can try. Evaluate integration 0 to 1 plus 1I x square minus iy dz along the curve y is equal to x. So basically from origin 0 comma 0 to 1 comma 1 using this curve C, okay, which is y is equal to x. Okay, y is equal to x is straight line. If y is equal to x, dy is equal to dx. Okay, so this is the hint, and you solve this question. Final answer is 5 minus I divided by 6. Okay, and if you solve the same question with another curve, okay, this is part the same question. Okay, you again try the same question along the curve curve y is equal to x square. Y is equal to x square means this is y is equal to x square. This is x. This is y. This is 1 comma 1 point, 0 comma 0 point. Okay. Okay. Y is equal to x square is a parabola. So you solve it, and in this case you should get answer y 5 plus I by 6. Okay, this is the difference. 5 minus I by 6 and 5 plus I by 6. So spend some time, and whenever you get free time, then you solve these questions, part A and part B. So this is A part of this question, this is the B part of the question. Yeah. So the first type of question which you can expect from the complex integral is just evaluate the integral. They'll give the function, complex function, and they'll ask you to evaluate along certain curve. Okay. Second type of question which we will expect is based on theorems. Okay. So in order to understand these theorems, in order to understand those problems, we should learn some theorems first. Okay. So let's start with the point Cauchy's integral theorem. Okay. Let's start the point Cauchy's integral theorem. If a function f of z is analytical at every point within and on a simple closed curve C, I'll repeat. If function f of z is analytical at every point within on and on the simple curve C, then integration over a closed curve C f of z dz equal to 0. Okay. So meaning is if your f of z is analytical at every point, then if you take a closed loop interval, if you take a closed interval of that function f of z, dz is 0 basically. Okay. The extension of it is, let's say, if f of z is analytical in the region D, which is in between two simple closed curves C and C1. Okay, so let's take the outside circle here is C, inside circle is C1. So our function f of z is analytical in the region in between these two simple curves. Okay, the shaded region basically. So the function is not analytical outside this region or inside this also. Okay, here this part, hollow part. Basically, it's a ring kind of shape, you can say. Okay, a ring kind of shape where d is the thickness of that ring. So here you can say integration over closed curve C f of z dz is equal to integration over closed curve C1 f of z dz. So in this case, you will say these two integrals are path independent. So if you are integrating around this curve C1 or C, it doesn't matter. Okay, unless your function is analytical in between C1 to C, you can take either integration along C or C1, you will get the same answer. So it's a path independent basically. Okay, so this is for the hollow circles, or sorry, this is for a ring shape simple curve, whereas this is for the closed curve. Okay, I would like to extend this further, like to let you know how this is derived. Okay, so look at this. So how I am splitting this ring shape curve is like this. I am making a small slot here. Okay, so from point A to B, then sorry, point A, C1, then B, and then C, like this. Okay, so A is like this point, these 2 points very close, you will call it as A, and these 2 points very close, you can call it as B. So A to B, then C1, then B to A, then C. Okay, so basically the C1 is in clockwise direction and C is in counterclockwise direction. So how the total integral will look like? Integration of f of z dz plus integration over c1 f of z dz plus integration from b to a f of z dz plus integration over c f of z dz. You know, from a to b, integral will be always equal to integral is equal to minus times b to a. So they should cancel out each other. Hence you can say integration over closed curve c1 f of z dz plus integration over closed curve f of z dz is 0. Here c1 and c. And they are taken in the reverse manner, right? So in short, they should be equal. So if one is positive, another has to be negative, then they will cancel out each other and they'll cancel out each other. Okay, so that is why this is how you can prove the Cauchy's integral theorem or the extension of the Cauchy's integral theorem in case of ring shaped regions where the integration over curve C or integration over curve C1 will end up with the same answer. And so you can say it's a path independent. Again, the extension of the Cauchy's integral theorem for multiply connected region. So previously what I said, C is outside curve and C1 is inside curve. But for example, we do have now C1, C2 and C3. In such case, integration over closed curve C f of z dz is not just equal to integration over closed curve C1 f of z dz, but you have to add integration over closed curve C2 f of z dz plus integration over closed curve C3 f of z dz. Okay. Okay. So previously we studied this part only, but now we are adding these two more integrals to it because here two more circles we are adding. Okay, previously we have just studied this is C and C1 and this was the shaded area, but now we have two more circles, so that is why the updated formula will look like this. Yeah, so this is about the Cauchy's integral theorem. So you will expect the problems which are based on not only just on the Cauchy's integral theorem but also based on the Cauchy's integral formula. So it is equally important to understand the Cauchy integration formula. So let's try to understand it. What is Cauchy's integral formula? If f of z is analytical at every point within and on a simple closed curve C, okay, and z naught is any point within C, okay, try to understand. It is not just integration over closed curve C f of z dz. We are dividing f of z to z minus z naught. So basically, if you assume this entire function as let's say g of z, then g of z is having singularity at z naught. Okay, f of z is not singular. F of z is analytical everywhere within the simple closed curve C, and let's say z naught is any point within C now. But how the function is looking like f of z divided by z minus z naught. So entire function will become now let's say a g of z. Then g of z will not be analytical because you know g of z will become infinite when z is equal to z naught because denominator will become 0 at z is equal to z naught and the entire g of z function will become infinite. So there is no question of analyticity. Okay, so this is a modified version if you remember or if you understand it here. F of z is analytical everywhere within the closed curve C, but we are dividing f of z with z minus z naught dz. In such a cases, this integration over a closed curve C is given by 2 pi I f of z naught. Okay, write down the formula integration over a closed curve C. Okay, f of z divided by z minus z naught dz is equal to 2 pi I f of z naught, and integration over closed curve C f of z divided by z minus z naught raised to the power n plus 1 dz is 2 pi I divided by n factorial nth differentiation of z naught. So if we are the question is like this, f of z divided by z minus z naught raised to the power n dz, then it will be 2 pi I n minus 1 factorial f raised to power n minus 1. So n minus 1 the derivative of z naught. Okay. So this is how the formula will vary. So they are more or less same. Any doubt till this? I hope you understood the Cauchy's integral formula. Cauchy's integral formula is applied when we divide f of z to z minus z naught. Okay. So we don't have singularity in z naught, but we do divide the z naught, f of z naught, with some function which is let's say z minus z naught in this case. So entire, let's call it as g of z. F of z is not singular, or f of z, rather f of z is analytical, but g of z is singular at z naught. Okay. So in such cases, you should use this formula: 2 pi I f of z naught, 2 pi I by n minus 1 factorial f raised to power n minus 1 z naught. Okay. So let's take some questions to understand this topic in more detail. Integration over a closed curve C, z square divided by z minus 1 by 2 minus I by 2 whole cube dz. So if you try to compare this with the Cauchy's integral formula, it is f of z divided by z minus z naught raised to the power n plus 1 dz is equal to 2 pi I by n factorial, n the derivative of f of z naught. Okay. Okay. 2 pi I by n factorial, n the derivative of f of z. Okay. So using this formula, how the things will look like: 2 pi I as it is. N plus 1 is 3. So it will be divided by 2 factorial and double derivative of f double dash of z naught. Right? And what is z naught here? Let me just rewrite this function. Integration over a closed curve C, z square divided by z minus 1 by 2 plus I by 2 whole cube. Okay. So basically z naught here is 1 by 2 plus I by 2. Okay. So here using the formula, it will be 2 pi I by n factorial. N is 2 here. So 2 factorial, double derivative of f double dash of z naught is 2 by 2 plus I by 2. Okay. So what is f of z here? Z square. What is f of z naught? Is 1 by 2 plus I by 2. Okay. Uh, Sorry, like not like this. So this is your f of z. What is f dash of z? 2z. What is f double dash of z? It is 2. So what is f double dash of z naught? It is again 2 itself. So 2 pi I by 2 factorial is 2 into 2. 2 will get cancelled, hence 2 pi I is the final answer. Okay. I hope you understood the method to solve these kind of problems. Okay. Let me mm, give one homework question. Same question I'll give, just little modification to it. Integration over closed curve C, Z square divided by Z minus 1 by 2 minus I by 2 dz. So I don't have any power to it now. Okay. Answer in this case you should get as minus pi. Okay. Very simple question. Same as before. We don't have any uh, differentiation here. You should use the formula. Hint to this is integration over a closed curve C, f of z divided by z minus z naught dz is equal to 2 pi I f of z naught. Two pi I f of z naught. So using this hint, you should try solving this question and okay. Yeah. Yeah. Before jumping into the next kind of question, if I hope you remember this, z minus z naught is equal to r represents the points on the circle. Okay. Z minus z naught less than r represents the point inside the circle, and z minus z naught greater than r represents the point outside the circle of radius r. Okay. I hope you understood this. Okay. If z naught is 0, this formula will become mod of z equal to r mod of z less than r mod of z greater than r at z naught equal to 0. Means these are the this is the equation of circle with the center as origin. This is the equation of circle with the center as z naught. Okay. I hope you are getting it. So based on this, we have some questions. Let me give one question. Integration over a closed curve C, z square minus z plus 1 divided by z minus 1 dz, where C is circle, option 1, mod of z equal to 1, and part B of this question is mod of z equal to 1 by 2. Okay. So try to solve these two questions. I'll explain how this try to solve it. Okay. And let me know your answer. Okay. So let me help you out with the plots here. Z not equal to 0 means it's a equation of circle with a center as at origin and radius as 1. And our singularity point z minus 1, that is z is equal to 1, lies on the circle itself. Okay. Whereas z naught equal to 1 by 2 is equation of circle with radius 0.5. Okay. 1 by 2, and our singularity point here z minus 1 lies outside here. Okay. Here 1 point is outside. Okay. With this hint, try to solve the question. So in which case you will apply Cauchy's integral formula? In which case you will apply Cauchy's integral theorem? So if you focus on the region here we are not here you will use Cauchy's integral theorem. What is Cauchy's integral theorem says? If a function f of z is analytical at every point within and on a simple closed curve C, then integration over a closed curve C f of z dz is 0. So answer for this question is 0 because none of the point on the circle with a radius 1 by 2 and inside it is basically singular point. Okay, at all point this entire function exists. Okay, that's why the answer for this question is integration over closed curve C f of z dz is 0. So the answer here is 0 for this question. What about the first question? You cannot apply Cauchy's integral theorem because on the curve we have singular point, that is z is equal to 1 is the singularity, right? So this entire function is not singular. But can you use the Cauchy's integral formula here? Okay, and what is Cauchy's integral formula? Integration over a closed curve C f of z divided by z minus z naught dz as 2 pi I f of z naught. So in this case 2 pi I, f of z is the numerator part and z naught is 1. So f of 1 will be 1 square minus 1 plus 1. So it will be 2 pi I itself. Okay. So hence 2 pi I is the answer in this case. Okay. So you have to focus on the question in such a way that you should be able to identify in which scenario you will use the Cauchy's integral theorem, in which scenario you should use the Cauchy's integral formula. Any doubt in till this? Feel free to ask if you have any doubt. Okay. I hope you are getting it. Maybe we will solve one more question here. Integration over closed curve C 2z plus 4 divided by z minus 0 dz. Okay, or yeah, z minus 0 dz, where C is mod of z equal to 2. Mod of z equal to is nothing but the equation of a circle with a center at origin and radius is 2. Okay, but and what is singularity here? Z is equal to z naught. Z naught is the singularity. Z naught is 0. So if you just put z also here, 2z plus 4 divided by z at z is equal to 0, the entire f of z, entire function, or let's say function, becomes infinite. Okay, so the function is not analytical everywhere within and on the closed region. Okay, so you should not use Cauchy's integral theorem. So because this definition of Cauchy's integral theorem is if function is analytical everywhere uh, uh, within and on the simple closed curve C, then integration over closed curve C f of z dz is 0. But here it is not analytical everywhere because at this particular point, the center point itself, it is not analytical because at z is equal to z naught, the entire function will become infinite. Okay, hence you should use Hence, use Cauchy's integral formula, and you will represent it as integration over closed curve C f of z by z minus z naught. Okay, so here z naught is equal to 0, f of z is equal to 2z plus 4. So in this case, answer is integration over a closed curve C f of z divided by z minus z naught is 2 pi I f of z naught. So it is 2 pi I. F of z naught means um, f of 0. Z naught is 0 means f of 0 basically. F of 0. F of z is 2z plus 4. So f of 0 is also 2 into 0 plus 4. So 4. 2 pi I into 4. So it is 8 pi I. Okay. I hope you are following it. Okay, let me give one homework question. You try it later. Integration over a closed curve C. Z. Or let's solve this question here itself. It's a little tricky. Z minus 1, Z minus 2 whole cube dz. Where see it Z minus 2 is equal to 1 by 2. So what is this equation? This equation of a circle with a center at 2 and radius at 1 by 2. So this is 2.5 and this is minus 1.5 and this is 2 point. Okay, so this is the equation of a circle. This circle is written shown like this, can be shown like this. Okay. Now, which are all the singular points here? If you consider the entire function, z is equal to 1 is the singular point. 1 will come here somewhere and z is equal to 2 is here. Okay, so basically this is singularity. So can I write this function like this? Because I want to represent it as integration over a closed curve C f of z divided by z minus z naught raised to the power n plus 1. Why I want to write it like this? Because we know that function is not analytical everywhere within the region, because the point at point 2 denominator will become 0, and if denominator becomes 0 the entire function will become infinite. So there is no question of analyticity. Hence I cannot use Cauchy's integral theorem. I have to use Cauchy's integral formula. So how the f of z will look like now? F of z will look like as z divided by z minus 1 divided by z minus z naught raised to the power n plus 1. So this is your f of z. Okay, so if you compare this, z naught is 2 here. Okay, so z minus 2 raised to the power 3. Okay, so using the formula, what is the formula? If you remember, integration over a closed curve C f of z divided by, let me just give me a minute. F of z divided by z minus z naught is equal to 2 pi I divided by n factorial nth derivative of f of z naught. Okay, so f of z is equal to z divided by z minus 1, right? So uh, first derivative of double derivative of f of z is 2 divided by z minus 1 whole cube. Okay, so f double dash of z naught is here 2, so this is z, f double dash of 2 will be equal to 2 itself. So integration over a closed curve C. So this can be easily written as 2 pi I double derivative of z at z is equal to z naught is 2. 2 pi I divided by n factorial, so it's 2 factorial, so 2 factorial and 2 will get cancelled. Hence 2 pi I is the final answer. Okay, I hope you are following till this. If you have any doubt, feel free to ask. Okay, let me give one question to you. Integration over a closed curve C. We'll solve this here. E to the power z plus sine z sine cube z plus cos of hyperbolic of z divided by z minus 3 raised to the power 5, z minus 6 raised to the power 4, z minus 5 raised to the power 3 dz, where C is mod of z equal to 3 by 2. C is mod of z equal to 3 by 2. So here, how the mod of z equal to 3 by 2 will look like? It's a circle with a center at origin and radius is 3 by 2 means 1.5. Okay. And what are the 1.5? And what are the singularity points here? Singularity points are z is equal to 3, 5, 6 are the singularity point. Okay. 3. Let's write 3 somewhere here. 5 and 6. Okay. So basically, we don't have any point, say any singular point within or on the closed region C. Do you agree? So hence we can say that the function is analytical everywhere within and on the simple region, simple curve C. And hence, according to Cauchy's integral theorem, integration over closed curve C, f of z dz is 0. If f of z is analytical everywhere within and on the simple closed curve C. Okay. Hence, the answer for this question is 0. Are you following? Do you have any doubt till this? Okay. So, yeah. So I think we have completed 2 topics from this chapter: complex variable. One is analyticity, and another is complex integrals. 2 more topics are remained. One is complex power series and singularities and residue. So maybe we'll complete it in the next session. Most of you have joined late, so we started this a little late this class, and we are at the end of the session. Just 1 or 2 more minutes are left, so I don't want to start a new topic here, which is complex power series. So let's end our session here, and in the next session we will cover these 2 topics, that is complex power series, and the last point is singularity and residues. Okay, very simple and small topics are there, but Yeah, it needs some time, so I will not be able to complete it now. So thank you all for joining this session, and let's meet again later. Yeah, thank you. Bye. Have a nice Sunday and Happy New Year to all of you. Thank you.